Good evening, everyone. Welcome. My name is Nicholas Demoncho. I'm the head of architecture here at MIT, and I welcome all those of us who are here in the room and also those of us who are joining online to our last lecture of the Spring 2023 lecture series here in MIT's Department of Architecture. I'm here briefly to both welcome and thank all of those who made the lecture series this semester possible, particularly Joelle Carrera and Amanda Moore and the Lectures and Exhibit Committee for all of their enormously hard work making these events happen. I will also give our land acknowledgement, which is a work in progress, as is the prospect of dealing with its consequences. MIT acknowledges Indigenous people as the traditional stewards of the land and the enduring relationship that exists between them and their traditional territories. The land on which we sit is the traditional unceded territory of the Wampanoag Nation and the Massachusetts peoples. We acknowledge the painful history of genocide and forced occupation of their territory, and we honor and respect the many diverse Indigenous people collected from time immemorial to this land on which we now gather. So with thanks to you all and acknowledgement to our guests, I will now hand over the microphone to our Dean, Hashim Sarkis.
Thank you, Nicholas. Good evening, everyone. My name is Hashim Sarkis, as Nicholas said, and I'm the Dean of the school. I am also from Lebanon, like our speaker tonight. And I'm grateful to Nicholas and to Huma for giving me the chance to finally end my self-recusal of declaring my admiration to Wael. This self-recusal started a while back, but I did know Wael from Beirut. Lebanon is a small country, and we got to meet several times around architecture circles. And I've always admired how nice he is. He's a nice guy, you will see. But also his deep commitment to architecture. And followed his work and followed him establishing his practice between Japan and Dubai. But then fast forward to 2021 when he was chosen to be the curator of the United Arab Emirates Pavilion in the Venice Biennale. And in May 2021, when we were setting up the whole Biennale, I arrived to see that there was nothing. The exhibition spaces were empty, the national pavilions were still in boxes, except for one, which was set up, and that was the UAE one, and Wael was smiling outside, saying, Hashim, come in. Well, I decided not to come in when everybody was there, because I didn't want to show any bias towards your pavilion. So one evening, I walk in, and there was no one except Wael, smiling. So I went in. And I saw this amazing installation of truly experimental, groundbreaking work about the future of building materials, set up in a space that looked like a laboratory. And I felt two things. One was that if all the pavilions will end up looking like this will be an okay Biennale. The second thing I felt is that this stuff should be shown at MIT. Fast forward, August 2021, the Biennale jury, headed by Kazuyo Sejima, who was here a few lectures ago, shared with me the night before the outcome of their deliberations, awarding the Golden Lion of that year of National Pavilion to the UAE. I was truly very happy, but I was worried that any association would be seen as being a bias. So I decided that night that I would not be the person giving you the award on stage. So I apologize for that in front of everyone, but now you know why. And it was the first time I think that the curator did not give out the Golden Lion that day. Fast forward October 2021, when the whole of MIT went to Venice, and Nicholas and John separately came up to me and said, we should bring that work to MIT. So finally, when Huma and all of you brought the work to MIT, I can finally say that this guy's work is great, that he's a good guy, and that we should not hold it against him that he's Lebanese. So, Huma.
Thank you, Nicholas and Hashim, and thank you for all of you for being here. I know this is a stressful time in the semester, so I know each of you have made tremendous sacrifices to be with us today and those online. It's also the last Aga Khan program of Islamic architecture lecture in the series this year, which I had the honor to design. I think Hashim, I can't say anything more than what Hashim can, except that is the first time I'm meeting Wael today in person, but I've met him on Zoom because he's been incredibly generous with his time and coming to my classes, meeting with my students, sharing his work, also evaluating some of their experimentations with concrete, which some incredible people here have been also working on. But I wanted to bring him here today because, first Hashim didn't tell me to do it, but because precisely his work is really inspirational. And I think all of you being here today is a testament to that the way he's thinking about architecture is the way that we need to be thinking about architecture, which means rethinking building material systems. It's not always the most exciting thing, but it's the kind of work that we have to do. And yes, so I'm gonna read the formal bio. Wael Al Awar is an architect and founding partner of Dubai and Tokyo-based firm waiwai. After returning to the Middle East from Tokyo, he founded waiwai, formerly IBDA Design, while layers his interest in natural phenomenon into an architecture of light, time, structure, and landscape. He seeks to create an architecture that is more than fabrication, that remains open to adaptation. His site-specific designs encourage unexpected experiences. Wael curated the UAE National Pavilion at the Venice Architecture Biennale in 2021, which you've heard a lot about. But you should also know that waiwai was named among the top 17 architects and top 50 influential designers of the year by Nikkei magazine in 2019, recognized by Architectural Records' annual Design Vanguard issue as one of the top 10 emerging firms in the world in 2018, and included in Architectural Digest's top 50 offices in the Middle East in 2017 and 2022. And to bring it home, waiwai was also shortlisted as a nominee for the Aga Khan Award in Architecture in 2019. So I think it's easy to say that this is the kind of work that we should be showing at MIT. And thank you so much, Wael, for traveling all the way across the world to show us and share your work today. Please.
Thank you. Sorry, I'll be sitting down. I'm quite jet-lagged and need to keep my bearings. Thank you, Hashim, for the very kind words. Thank you, Humma. Thank you, Nicholas, for having me here. I'm really honored to be presenting my work and the work of waiwai today. To give Wetlands some context, I would like to start with brief examples of waiwai works. We have 6 design principles that we adopt for all our projects. Sometimes some are emphasized more than others, but in principle, we accommodate all to a given project. I will start by giving a brief introduction into each principle and how it is implemented in a project. The first principle is cultural and contextual sensitivities. It is important we understand our identities and our culture and how these relate to the production of space and architecture. Also, understanding the different geographies and how each have unique climates. We look at that in detail to ensure each project responds to its context. Although a mosque has the same program, mosques have been designed differently in each culture. For the renovation of the Mosque of Reflection, we demolished the boundary wall and all other functions except for the male and female prayer halls. Then we introduced a riwak encircling the prayer halls and opening the mosque to the public and the neighborhood. The mosque was always a communal space and not only served for prayer. Until today, I receive calls from the imam complaining about the neighborhood kids playing on their bicycles in the riwaq. He thinks it's a bad thing, but it puts a smile on my face. The second design principle is interest in phenomena, natural light, activity, wind, time, etc. Here, we study in detail the natural light for Al-Warqa prayer hall, which is called a haram. We study the difference between high side light and top light. This study is done by physical models that we produce and analyze under the sun. We can then track the behavior of the natural light accurately within the haram space by month, day, and hour. This is a photo of the haram naturally lit by the top light we deliberately wanted to have as a serene, homogeneous light condition that allows one to focus on the ritual of prayer. The third principle is the synthesis between architecture and landscape. I don't see a boundary between the two disciplines. The painting by Pieter Bruegel, titled Play of Kids, as well as the souk photo from Jeddah some 100 years ago, were the source of inspiration for the design of Hay Jamil in Jeddah. Both offer a space of gathering and play, bringing people together. The building is designed around a single courtyard that brings the multidisciplinary design program together, forcing them to speak to one another. It also offers a space to host music festivals, an outdoor cinema program, etc. The fourth principle is architecture beyond functionality and program. It is important to think beyond the pragmatic sense of architecture. This was a competition proposal for the Beirut Museum of Modern Art. We proposed a semi-outdoor exhibition terraces inspired from the Japanese word komorebi, meaning the sunlight that filters through the leaves of trees. This was not a requirement in the brief, but we wanted to propose a naturally lit new space for the exhibition of art. We believed this was a very contextual proposal to Beirut. For those of you who know Beirut, it screams concrete. We thought in 2016 it was time to interject a new building typology, one that is light, transparent, and open. Unfortunately, we were so wrong given the tragic explosion on August 4, 2020. The fifth design principle is the diagram of relation and not the diagram of form. We do not start with a form and then try to fit the program into it, but rather we start with relations, asking ourselves, how do we want the activity to be within the space? How will this building relate to the context, etc.? Here I show Heidi 3 that was built from 82 shipping containers and with no additional steel reinforcement. The client wanted a 3-year temporary building, and Dubai is home to one of the largest shipping ports in the region, with hundreds of containers being commissioned yearly. The project was completed in 2015 and is still standing today. The sixth principle, the last principle, future vernacular, is about sustainability, constructability, and ecological material sourcing. Here, I will move to present Wetland that was presented at the 17th Architecture Biennale. I must point out, this is an ongoing research project. Venice exhibition was only a pit stop. When Hashim asked the question, how will we live together? As practicing architects that are desperate to build sustainably, we wanted to address the relationship between us humans and our planet Earth. As Hashim once said in an interview, we wanted to bring a multicultural and cross-disciplinary dialogue that is up to par with the Mos Eisley Cantina from Star Wars. But with the postponement of the Biennale by 1 year, the Curators Collective was born. And this was born through the call that the Korean curator initiated for all National Pavilion curators to meet on a Zoom meeting. And from that meeting, another project was also born, which was titled A Bench in Venice. A Bench in Venice called for students around the world to design an upcycled bench using the 17th Biennale of Architecture installation leftover construction materials. Launched by the inaugural Curators Collective in collaboration with the National Pavilion of the UAE, this open call puts forth the idea that a bench can be a key activator of common space, enabling observation, reflection, and therefore dialogue. As the world continues to grapple with today's twin urgencies of the pandemic and accelerating climate change, the need for dialogue is greater than ever. For the first time in the Biennale, a cross-national pavilion project was realized, and thankfully to the support of Hashim Sarkis. We collected materials from different pavilions, wood from the UAE Pavilion, as well as salt brine blocks from the UAE Pavilion, wood from the Japan Pavilion, canvas from the Canadian Pavilion, and clay bricks from Vocht Landscape. That were part of the catalog of materials that were included for students to use. We received 136 submissions from 36 countries, I believe, or 38 countries. And we went ahead and exhibited all their works and all these submissions within the UAE Pavilion, as well as realized the 3 winning benches. One was put on display in the UAE Pavilion, one was exhibited outside the Spanish Pavilion, and the third finally exhibited in front of the Japanese Pavilion. And this was for the first time that multinational, the national pavilions come to talk to one another and realize a project that is not only initiated by one national pavilion, I would say. Now, we move to wetland. Why wetland? During the course of this presentation, you will understand why the title of the exhibition was Wetland, in Arabic reading Ardun Ladina. Today, we live on an Earth with a population of 7 billion people, and it is projected by 2050 we will grow to 11 billion people. A Bill and Melinda Gates Foundation report in 2019 states that we will have to build the equivalent of 1 New York City every month over the next 40 years to meet that growing demand of population growth. The question is, how will we do that knowing that we are already in a state of a climate emergency? We also need to know and understand what is the responsibility of the construction industry on this climate crisis. If we look at emission, the construction industry is responsible for 40% of global emissions. Cement alone is responsible for 8% of global CO2 emissions. Concrete is the second most consumed resource on the planet after water. Today, we consume 30 billion tons of cement yearly. It is projected by 2050 we will consume 60 billion tons of cement every year. The mathematics don't add up, and we really need to find alternative solutions. Cement is also an archaic dumb material, meaning that to produce 1 ton of cement, you emit 1 ton of CO2, which requires a tree over 40 years to absorb that amount of CO2 emitted. In addition, the construction industry and architecture is still based on the mindset of extraction. We are responsible for 40% of resource depletion. Energy. The construction industry is responsible for 36% of global energy consumption. 86% of that still comes from the burning of fossil fuels, and 14% comes from renewable energy. Excess. We are responsible for 40% of global waste. As Dr. Philip Block states, 40% across the whole board. The the modern architect was not challenged, I believe, with this issue of the climate crisis. It is a recent phenomena that is put against the 21st century architect to probably challenge. But while I was curating the UAE Pavilion, I came across this article that was published in Domus magazine that caught my attention, and it was a letter written by Jacques Herzog to David Chipperfield, who was at that time the editor of the magazine. He wrote, "Dear David, you asked me what we architects should do about the unmistakably impending environmental catastrophe, about social inequality, about poverty, about the degradation of the planet's resources, about the pandemic, which has placed us in an almost surreal mode that begs description, all of which is being managed by political leaders whose cynicism and absurd actions put the Marx Brothers to shame. Dear David, the answer is nothing." So I came to ask myself, who is this 21st century architect and what is my responsibility? Others responded in the Venice Biennale by returning to vernacular architecture as well. The Philippine Pavilion proposed a pavilion built from sustainable wood under the concept of mutual support. So did the US Pavilion. But in the United Arab Emirates, the vernacular architecture is built from corals. So for me to go back and use coral to avoid using modern material is impossible. It was okay probably for a few hundred people, but today the UAE population is at 10 million people and growing at a tremendous rate. So I had to go back and try to look at what is the problem in concrete and is there a solution probably to that. So once I started investigating the problem, I came to learn that the biggest problem is in the lime, which is in the binder of concrete. And converting limestone to lime is what releases a tremendous amount of CO2. And it's not due to the excessive heat required to produce cement. This is a myth. It is mostly due to a chemical reaction of converting CaCO3 to CaO that releases CO2. So the question became, can I find a binder that is different than lime? So the answer would have to lie within the geography. So I started looking at the geography of the UAE and trying to understand the different minerals in that geography and if anything could be an alternative solution to lime. I soon came across the sabkhas of the UAE. Sabkha is an Arabic word meaning salt flat found in the English dictionary. I was immediately captivated by the cementitious crust on the top of the sabkha, and I was sure there was a binder within that crust that is binding all the minerals together that could possibly be an alternative to lime as a glue. And sabkhas are not a local phenomena, and there are two types of sabkhas in the world. There are coastal sabkhas, like the one I showed before in Ruwais, or also what they call continental sabkhas found in the deserts. And this is another sabkha that's found in the Siwa in Abu Dhabi. Sabkhas are also a global phenomenon. You find sabkhas, salt flats in the Mojave Desert, sabkhas in Bolivia. The sabkhas in Bolivia are mined for their lithium. They are used in Tesla car batteries as well as in making cell phones. Also sabkhas in Ethiopia, and then we came across Siwa in Egypt. And Siwa is a town that is 900 years old, that is all built from its local sabkha and still standing today. It is a contextual architecture built from its earth and that adapts and responds directly to its climate. Another interesting fact we came across is that also the architecture in episode 4 Star Wars is built from sabkhas and is not actually a stage set. This is in Châteaugiron in Tunisia. Sabkhas are carbon sinks. They absorb CO2. 1 square meter of sabkha can absorb more CO2 than 1 square meter of rainforest. Then hence, we cannot promote their extraction and use as a building material. So we needed to find another place where we could source these minerals that could alternatively be used as a construction material. Through a very lengthy and tedious process, we learned that the answer lies in the reject brine of desalination water found in the Gulf and the UAE specifically. The MENA region is responsible for 48% of global desalination. The UAE is the third largest desalinator in the world. KSA is number 1 and USA is number 2. The UAE produces the equivalent of 4,800 Olympic-sized swimming pools of reject brine daily that are dumped back into the Arabian Sea, causing an environmental disaster within the sea. So we thought, let's try to take some reject brine and start experimenting in the office if we could produce architecture with that brine, knowing that the minerals in that brine are the same minerals that are found in sabkha. The first experiments were very basic. We simply submerged fabrics in the reject brine. So fabrics that work in tension over 3 days crystallize and start to work in compression. And from that, we could produce basic structures. But the problem with that is that these structures absorb humidity and could collapse. So we were not convinced at stopping there by producing temporary structures. We wanted to really challenge ourselves and push the limits in order to produce more permanent and stable structures. So we learned that basically we couldn't do all of that on our own in the office, and we had to start collaborations with university laboratories that are more equipped with science. Our first collaboration was with the American University of Sharjah, where they took the reject brine solution and started to analyze and look at the different minerals found in the reject brine. With them, we started to separate the different minerals and started to produce also different forms and types of architecture made from salt. But again, all these experiments were offering us temporary structures and not permanent structures. But we learned from the biochemistry lab at the American University of Sharjah that there was one salt that could offer us a permanent solution, which was magnesium oxide. Through more research, we came across Dr. Kemal Çelik at NYU Abu Dhabi, who was also working with magnesium oxide-based cements, and we started a collaboration with him on trying to investigate and understand how could we extract MgO, magnesium oxide, from the reject brine of desalination water, and from that produce cement blocks. Soon we were able to produce cement blocks using magnesium oxide, and these were non-soluble cement blocks. A fact I should state is that the Great Wall of China is built from magnesium oxide cement. But today, we cannot also go back to thinking and using magnesium oxide based on the extraction ideology, and that's why it is important that we source the magnesium oxide from the reject brine of desalination water. But through our initial experiments, we quickly learned that, of course, this material works in compression, but we learned that it is very weak. And through experimentation and the support of the lab, we learned that the material needs to absorb CO2 in order to gain its structural strength. It will absorb 18% of its weight CO2, and that will be called a carbonation process and will give it its strength. It's not a fancy process. It's simply exposing these prefabricated modules to a carbon chamber. It could be as easily as a block put into a plastic bag that is also filled with CO2 and left for 72 hours to carbonate. I'll show you a simple video that shows one block non-carbonated, one block carbonated. The test was done at the factory in Venice because all the modules and units we produced were in Venice to test that the results were. You can immediately tell the carbonated module that does not break versus the non-carbonated module that completely shatters. Now, after having come up with a material that is magnesium oxide cement, we had to go and present in Venice. We didn't want to only present a modern material, but we also wanted to re-question modern methods of producing space and architecture. Hence, we started a collaboration with the University of Tokyo in which we wanted to have an homage to the coral architecture of the UAE. Here, we thought that we would design a pavilion that is built from modules, all inspired from coral shapes that are drawn into sand molds. So we asked students to imagine coral shapes, draw them by hand into sand, and then which were then cast by MgO cement and then carbonated before building with them. The first module was built at the University of Tokyo, and here pay attention to the scaffolding and the devices that are placed on the scaffolding, as well as the student on the ladder with the device in his hand. I'll explain that a little bit further later in the next step. And then we built a second prototype in our lab in Dubai, which is based in As-Sirkal. And the lab is currently still up and running with the experimentation of prototype 2.0. But we are keen on vocational learning. So students from Tokyo University were in constant conversations with students that were interning at the Wetland lab in Dubai, and they taught them the whole process in order to execute the second prototype in As-Sirkal lab. Here I said we wanted to produce and present in Venice a pavilion that is the antithesis of modern structure and architecture. So this prototype actually does not have any drawings. It has just a construction manual that teaches one or guides one on how to build this prototype. The role of the architect is diminished in this scenario. So the architect that usually designs a building that, while he is situated in Dubai, designs a building in Brazil and sends the drawing there, and that is built accurately to a millimeter, doesn't work in this scenario. Here you can just send guidelines and a catalog that guides the workers on how they can produce that prototype. Wetland, we started to set up in Venice, and then the first step was to actually set up the base station of the computer, and then build the first layer, and the devices that I had mentioned earlier here I will explain in more detail. So building a random looking structure also needs to be structurally calculated, right? You cannot just put it together and hope it will not fall. The Biennale is a public event that is visited by hundreds of people, so we had to confirm to the Biennale that this was a structurally stable prototype. So the lab in Tokyo University run by Obuchi-san reprogrammed devices from the Wii gaming industry that helped us build that prototype in a way that allowed us to calculate it structurally, and I'll explain that in more and more detail. But the small image you see here is actually just the outline of the form. So the modules are created. Each module is different because each student will draw the module he imagines in a different way, but we control the form. And why do we control the form? Because we have a limited number of modules that we can build with, and also we had to ensure and control the egress routes in the Biennale in case of emergencies. So then that form is projected as a hologram onto the space through the devices that are, I don't see if you see my mouse, which are these devices that are connected to the ceiling, and a hologram of that is projected. The hologram is not visible to the eye, but is actually read through wrist devices that the builders wear as they are going. So here you can see as they are building, if the wrist device is lighting up blue, it means he is within the model space of the form that is being projected. And it does not only work horizontally, it also works vertically. So you control both the X and Y directions. As I said, there's no prescripted drawing to assembling this prototype, so it's only done through conversation and dialogue. And here, I am conversing with Pietro and others to see and negotiate how to put these modules together and which module is more suitable to interlock with the other module. Again, I should mention that this process is built in 7 layers, and upon completion of one layer, we will have to stop, scan all the modules. These modules are then uploaded onto an as-built model on the computer, and that is in direct link with Tokyo University that check that model and verify if we can proceed to the next layer. Here, I'll show you a video of this, explaining this process further. Yes. 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 So here you see they're scanning each module, and with a chalk, you just put an X to make sure that you don't scan it by mistake again. And that's uploaded to an as-built model. And this other video shows you how the whole system works. So wrist is blue, meaning he's within the model form. You see the computer with all these scanned modules already showing on the model. The base point. And the devices that are projecting the hologram, the outline of the volume that is not visible to the eye, but just read through the wrist devices that they are wearing. It actually, funny story is that when we set up first the base station and we projected the volume was bouncing in the space, actually. It was not, and we'd never experienced that in Tokyo or in Dubai. So we're looking at the computer, and we can see the volume model that I had shown before, just bouncing on the walls and bouncing around in space and not fixed to the particular location we wanted it. So it wouldn't work, meaning that the blue marking wouldn't work. People would have to run all over the space. And it took us 2 days to figure out, after rigorous attempts of switching things on, switching things off, that the boombox of the contractor on the second floor had the same frequency as the internet in La Biennale. And the problem was that the frequency of the internet in Italy is still on 2 gigahertz, while in Dubai and Japan, I think is 4 and 5 gigahertz. So you will never have this kind of problem of the simple device of a Bluetooth radio competing with the virtual internet world. And yeah, once we solved that problem, it was a great relief for us. And you see here, so connected to the, the points are scanned, uploaded. We'd have Zoom meetings. You can see Sato Sensei there, which is the structural engineer in Tokyo University, confirming the integrity of the structure and giving us the go-ahead to start building the second structure, and finally having a structural verified model that is submitted to La Biennale to allow us to open the pavilion to the public, because before that, there is no way you can open it to the public without this assurance. Finally, the pavilion was built from 2,400 modules, all assembled, I would say, through conversations. And we also commissioned Farah Al-Qasimi, an Emirati artist based in New York, who took amazing photos of sabkhas in the UAE that capture the tension between landscape, the natural, as well as the industrial grid above. And you can see in the background there the desalination plants and the oil rigs that are competing with this living landscape. Because sabkhas are living landscapes, they're constantly shifting because of the movement of underground water. Final slide. I would like to to present to you an audio, and this was commissioned by us and done by Lawrence Abu Hamdan. And the audio speaks of the life of Artemis, which is a shrimp that is living in the Arabian Sea. I've overlapped it with a time lapse of the assembly of the pavilion just to make it a little bit more lively.
The blowdown pump of the desalination plant spews superfluous volumes of brine discharge. The continuance of this continuous expulsion dramatically increases the salinity of the sea. These conditions produce an inhabitable anoxic zone. Our friend Artemis is classified within the genus of Artemia, within the family of Artemiidae, within the order of Anostraca, within the class of Branchiopoda. She is an aquatic crustaceous arthropod. Artemis lives within the vicinity of the coastal sabkha, the desalination plant, and the coral reefs. Because of the seawater's hypersalinity, she lacks oxygen and is battling the reaction between her chitin exoskeleton and the acidic sea. Her exoskeleton is comprised of a polysaccharide. This degrades due to acidosis, pushing her out of homeostasis. The process of acidic erosion causes Artemis to expend an increasing amount of energy to build and rebuild her shell. As more brine is expelled into her world, Artemis must work exponentially harder to survive. She switches her reproductive mode in order to produce dormant eggs, which she hopes will survive and outlive her unstable environment. Her efforts will be in vain. Acid cuts carbon. Artemis does not simply suffocate in the deoxygenated water. Her exposed body calcifies. Her exoskeleton dissolves. The blowdown pump of the desalination plant spews superfluous volumes of brine discharge into a reservoir. The brine is then transported to a concrete manufacturing plant. Here, it is processed to yield a purified brine rich in magnesium chloride. A reaction with slaked lime or dough lime precipitates magnesium hydroxide. The resultant slurry is filtered, washed, and calcined to form magnesium oxide. The magnesium hydroxide reacts with dissolved carbon dioxide to form hydrated magnesium carbonates. The formation of these hydrated magnesium carbonates provides a binding ability, establishing an interconnected network, strengthening the concrete and allowing it to perform structurally. Our friend Artemis is classified within the genus of Artemia, within the family of Artemiidae, within the order of Anostraca, within the class of Branchiopoda. She is an aquatic crustaceous arthropod. Artemis lives within the vicinity of the coastal sabkha, the desalination.
It's looping. Yeah, sorry about that. Thank you. Finally, I ask the same question I asked at La Biennale, which is, can industrial wastes produced by our cities be the future vernacular? Thank you.
Hi, Wael. Thank you so much for your presentation. I am a first-year PhD student in building technology. My name's Kylie Fikert, and I'll be helping with Q&A tonight. So I'll kick it off with a question, but then please, we're very interested in questions from the audience as well. So if you have a question, please let me know. I wanted to start, my background is in architecture as well, and in my experience, the kind of normative design process is starting with forms, as you say, and then applying materials to these forms. But what I'm really interested in your work is this idea of starting with the material and seeing how that leads to kind of different spatial qualities or effects that are not normative by any means, as I would point out in this image. So I'm really interested to know where you see this heading in terms of other materials that you're maybe exploring, or other spatial qualities that you think can be achieved by using this material process that you haven't explored yet.
Yeah, the question is, what is normative? That would be my question, because this is, the norms we know are based on materials we know. So this is a new material, and this material needs to absorb CO2 to gain its structural strength. So we need to, once you start investigating with material, you have to work with their properties, and then their properties will lead you to maximizing their potential in producing space. And that is, I think, the way we need to think and approach the subject. If we try to take this material and build with it in the same way we build Portland cement, is actually impossible, because this cannot be used as a cast in situ system. It has to be used as a prefabricated system, because you need to expose it to CO2. Otherwise, if it's in cast in situ, the shuttering won't allow you to do that. And then the other thing is that since this is a salt-based cement, means we cannot reinforce it with steel. So actually, all these modules are reinforced with natural fibers. In Dubai, we use palm fibers. So we had palm trunks, we would crush them, use the palm fibers. So in Venice, we use natural fibers from local trees. So then, we need to rethink the whole system. We need to find new systems. We cannot re-adopt the systems we have, as they've definitely failed us.
Are there any questions from the audience?
Hi, well, thanks so much. It was really, really inspiring. To piggyback on what you said, how can this be scaled up or standardized in the same way that the domino structure was for structural concrete? How can this, because you've investigated in a very inventive way, like a new material, a new process, how can this be standardized and, brought to the masses in ways that the same vehicle was used, for, structural concrete,
yeah,
with the domino
exactly.
structure?
So that's what I'm working on right now, actually. That's prototype 2. So prototype 1 for Venice, it wasn't necessary to be pragmatic. We didn't have to show people, or actually our interest was not in figuring out how to be pragmatic. Our interest was really to raise questions and to engage in a broader dialogue and to re-question modern architecture and the modern production of space and try to bring back craft into the production of architecture and as well as identity, I would say. So now in prototype 2, we're really working on trying to create an optimal module, but I don't have an answer yet. We will be exhibiting in an upcoming exhibition in September, and we plan to have the prototype 2 ready for that. Hopefully, we'll have more concrete answers on that soon. But I think it is important that we don't stay poetic, and we really also propose a working system in order for this material to really compete in the market against Portland cement. Otherwise, we will stay on the fringes of cool material for exhibitions.
Other questions?
I'm happy to add one. Thank you very much, Wael. It's a pleasure to hear from you on the pavilion. Maybe I'll push back against this idea that you're taking away from the agenda of architects. I think you've given us much on where that agency might lie, maybe in ways that might be asking us again to think of the relationships of material to larger territory, industrial processes, externalities of these processes as material for the future. So I'm thinking about it as a pedagogic project, and one question that I had was on the set of the expertise that you thought were necessary to begin to assemble such a project that might rest outside of kind of a curriculum. So what would the sabkha curriculum imply in terms of exposing collaborations, and how did you come to these collaborations? Yeah. A second smaller question after that, but maybe if your time allows you, is I think I started with that super kind of ecological image of the reef as an inhabited ecosystem, and you kind of leave us with that shrimp that doesn't seem to be thriving in the world. And I'm wondering if part of the thinking of materiality was not to kind of remove that matter from its living quality, but to allow that matter maybe to continue to be in relations with water, shrimps, and others. So I'm wondering if either version 3.0 might begin to allow us to think of that relationship between the organic and inorganic in maybe a way that amplifies the potential of that material vernacular in a way.
Yeah, I mean, the first question about the multidisciplinary team and how do you come by, I mean, it's really a step-by-step process. And it's a very much like you work like a journalist, and you try, you do your research, you investigate online, and then you say, okay, this is where I said at the office we could just push it so far, and then we realized, no, we really need a biochemistry lab. So then, we go out, we ask who are the biochemists in universities that can help us with this project. So I do a few phone calls to the universities I know, and then they proposed Dr. Lucia from American University of Sharjah, who was very willing and interested to collaborate immediately. And then her input in understanding and teaching me what insoluble salts versus soluble salts mean. And, I had to listen. I was fortunate enough also to have time because of the pandemic, and the practice was very slow. So that also honestly helped a lot in trying to focus outside, our frantic lifestyle as architects, where we get pulled into construction sites to deal with silly stuff sometimes, but very nonetheless, I mean. And then that takes you to another, and then you hit a certain point and you realize, oh, I need to collaborate with someone else, and the skills need a material science lab, and Amber Lab, the Advanced Material Building Research Lab, and NYU had that skill set. So, you know, you complete a phase, and then you realize, I need to go to step 2. Who do I need to help me get there? And this is how it was, actually. There was no master plan. There was no clear vision. It's just you go, and today I'm working with Khalifa University that supply us with 250 grams per week of MgO cement from their lab. So I get a package, you know, from them that we prototype with. And it happens because they are getting funding to support us on that. So, your second question, yes, I totally agree with that. Also, I think, you know, true. It's also when we thought of this structure, we also wanted to think of architecture as an organic thing, yeah. And the this prototype, I wanted to actually put it in the sea in Venice, yeah? So it becomes an artificial reef, because the idea was it was a coral, but winning the Golden Lion, suddenly it became gold and not MgO cement. So then it's way, you know, then now it's in Abu Dhabi. It will be presented at COP28, so we couldn't, yeah, we couldn't make it into a coral reef, because I think it would perfectly work as a coral reef in the water, definitely. And that was the idea, actually, because we shipped nothing to Venice. Everything was produced locally.
Hi, Wael. Thank you very much for your talk. I wanted to actually pick up on where you ended in the talk, which is this idea of future vernaculars, and to go back to the question of standardization, because those two things are a little bit at odds. And when I've spoken to you a lot about this project, and I know that the idea is to create something that's like context specific, right? From a particular form of industrial waste that comes from a particular place.
Right.
And so now with this module 2, there's an idea to make more standardized. And I'm just wondering if you could talk a little bit more about this idea of a vernacular, right, versus standardization, and how you've been thinking about that in this material, and also like how that thinking maybe has developed throughout your project.
Right. This is, I mean, yeah, I mean, here, vernacular has many connotations, right? It's not only in production of space, but it's also the materials found in nature, right? So modern material are global material, you know. So we look at, you know, industrial wastes of the city, and see if that could become something that could offer you a building resource. When asked, can we propose this in Japan? No way. I mean, there's no desalination in Japan, but I think this would work perfectly in West Coast USA, because this is the second largest desalination area in the world, right? So when you say, you know, future vernacular, it doesn't need to be, when you look at it as waste, it doesn't need to be only based on your geographic location and context like vernacular architecture is, which has to do a lot with the climate, but here more with the large productions that your city needs, your infrastructure. The word is infrastructure. Does that make sense? Yeah.
Just a quick question about weight.
Yeah.
It looked like you can pick it up pretty easily, but I mean, I saw some crates with
No.
so to talk a little bit about the weight.
The weight is the same as Portland cement. The weight of the density of the material, actually.
Same as concrete?
The same as concrete, yes. Which is 2.5 kilonewton, I believe, per kilogram.
Thank you all for a great talk and for informing us on all this really great work. I mean, this is a question zooming out a bit more. I think you've presented to us a facet of the UAE that not many people have access to and see, and I commend you for that. I wonder, though, how does this get presented inwards? I think Venice is a great platform to bring these issues to the table, but the UAE also, I mean, I just think culturally as well, what is the reception of such forms of materiality, and how do you introduce this to an industry inside? Because I think this is a widely celebrated project, and I think the UAE is very proud of this great accomplishment. But I wonder, how does it manifest further down? So it's beyond the golden lion, and it's more something that is truly accepted, not just as this accomplishment, but as practice.
Yeah, I mean, now, you know, Aserkal lab is still, wetland lab is still functional. We still get funding. We still get support. So we get support from the Ministry of Culture. We get support from Dubai municipality. The support is not only financial, but also access to material. How do you get reject brine of desalination water? So you need access to the DIWA authority facilities that facilitate the material for our ongoing research. Otherwise, it's impossible. We also have access to interns working in the lab all the time through the support of the Ministry of Culture on the educational facility, educational institutions. For example, we will receive next 2 weeks or 3 weeks, 6 interns from 4 universities that will work with us for 2 to 3 months as part of their credits at university. So we get that support also coming all the time. So the support is there. I mean, I need to keep the drive up to just, you know, make sure that no one loses interest, because again, Portland cement is the second most consumed resource on the planet after water. So it's so easy, it's so cheap that no one wants to go out of their way to implement a very difficult and complicated system if they can just keep going the way they're going. So, but you need to keep ringing the bell and saying, you know, we need to do this. This is the future. We can't do that. That's how it is.
As we wait for others, maybe I can ask a question.
Yes.
First, thank you so much again. Every time I hear you talk about this, I sort of learn something new. And I have 2 questions that are sort of interconnected and building off of Latifa's question. And I know Latifa is deeply also engaged in this question of alternative cementitious mixes and how to actually structurally execute these, you know, these alternative building materials, and also not only structurally, but aestheticize them in a way that is desirable. So this question of like, what is the agency or role of the architect, which Rania also mentioned, is to also sell a different aesthetic of what is aspirational and desirable for, you know, people of all walks of life to want to inhabit or live in or frequent or visit, you know, so that's certainly very strong. But I think the other big challenge, which I know you've shared before, is how to get the, you know, structural engineer and international building codes to allow for a different form of building, which, you know, what I've learned from Latifa's research and others' work is that, you know, these building codes, some of them haven't changed for decades, and contractors, people on the ground who are actually building don't want any legal liability. So that these are the very real on the ground challenges of construction and getting people to adapt. So I guess I'm just curious, knowing what you know and the fact that you're relentless in your pursuit of, kind of changing people's minds, but also changing the industry, how do you sort of take a two-pronged approach? One, on the kind of forefront of aesthetics to make this something desirable, and the second, to, like you have your structural engineer in Tokyo sort of sign off on this one, how do you sort of get buy-in from those actors in the industry?
Yeah, this has to do with legislation and government again, yeah. And then if they have a buy-in, then you have the support. But these are lab tests. They're actually not that difficult. In the last year, I was intimidated by all of this, thinking that this is kind of impossible. But actually, it's not. It's quite simple. There are criteria that you follow to produce the lab tests, and we found someone who can do it for us in Germany, actually, and they can do it within 6 months to 1 year, the whole testing process. And then once it passes this, you will get the certifications that you need that give it the specifications. It's actually, and specifications are always built to protect markets. So you have the British standards, you have the American standards, and then you have Japanese standards. And if you're building in Japan, you can't use any non-Japanese certified product. No way. Even though it's a very well-known brand in the US, etc., you still need to get a local certification from Japanese labs. And these are designed for, the protecting the economies, I would say, right? So it is not intimidating. It could be done, but you also need the support of the government institutions in the process, of course.
Sorry, a quick follow-up. You said this is going to be exhibited at COP28
Right.
in Dubai. Are you planning to have some sort of conversation, because government leaders will be there around this?
Yes. I will be probably one of the speakers at that. And then I didn't mention that. I presented this research about 6 to 8 months ago at UNESCO. And then there were 52 delegates, from them about 10 ministers, and the rest were ambassadors. So no, there is serious buy-in from global community in trying to support this kind of new thinking approach, right? But again, I am an architect. I can help in facilitating a conversation and driving a team on how we need to think, but we need the scientists to extract the reject brine from desalination water and find the most efficient way to extract. Because again, if they extract using extremely high energy processes, it just makes no sense. Then you're still failing. So now Khalifa University is extracting using solar energy. And given the UAE and all the sun we have, so it's a very efficient way of extracting. But it's a multidisciplinary team that needs everyone's buy-in to make it happen.
Thanks. This is totally fascinating. Thank you so much. I'm curious about the video, and if you could talk about how the video was put together. It strikes me that there are two things of interest for me. One is the way in which the persona of the shrimp is used to connect all of the interdisciplinary elements that you've put together. So I'm wondering who wrote the script and how you put all that together. Somebody raised the notion of a pedagogical tool, and I think this would work wonderfully in a whole series of environments. And the second question follows on the question about maybe 3.0, the organic component in the future, what I see there, just in the form, it strikes me as very much like the artificial corals that are being built around Sulawesi and elsewhere in Indonesia. So I wonder if there's some sort of fusion element there, some sort of carryover.
Right. Regarding the audio, yeah, I mean, the script was written by a dear friend, artist, Turner Prize winner, Lawrence Abu Hamdan. His name is not there in the Biennale because he didn't want it there. But then I asked him, I said, can I show this at MIT in the lecture and mention your name? He said, okay, just go ahead. So he did write the script. It was an idea that we came up together with, but you know, he's a sound artist and he has the power and the creativity to do that. And 3.0, yes, actually, of course, you know, again, I do think even 2.0, version 2.0 is not, you know, you have to wait, and I have to wait to see what the outcome will be. But it's, again, it's not a typical house that you imagine is 2.0, not at all. It still has a very organic form to it. I mean, it needs to breathe. It's a breathing structure, I would say. It's a breathing structure because in order to carbonate something, it needs to be porous. And the corals are porous. Again, it goes back to being an homage to the coral architecture. And so it's always a breathing block. And the block is not, we'd never imagine it as a square block. Again, it needs to bring identity and craft, you know, into the production of space, but maybe, you know, this didn't have a roof to it. It was open. We didn't attempt to close it, although I wanted to, but there was too much risk, and then we had to stop somewhere. Although the team was keen on going the full way. Now, after COP28, I think I can take the modules and do try to close it and see what happens. But of course, yeah, it's not at all going to go into the direction of a prefabricated house that you and I imagine as a stereotypical form of construction.
Hi. Thank you for this really great lecture. It's always inspiring to see an architect working with materiality and exploring the physics of the actual thing that you're building with. What I thought that's really brilliant about the work is that you're using the waste of the desalination plant of the UAE to produce this cement, which is also interesting because the desalination plant is environmentally catastrophic, but also the UAE really depends on it. So I was wondering, what is your position on that? Do you see like the future where we always need a higher demand for building, a future where we only use or like develop new things by using the waste of these massive scale construction techniques? Or do you see that ideally we should use a local material that doesn't come from waste? Because also it was poetic to see that you didn't use the sabkha just because it's a really nice natural occurrence, but also because it didn't work out mathematically.
Yes, of course. What, you know, using sabkhas again goes back to the idea of extraction and depleting resources. And you know, this is not an intent at all, especially something like a sabkha needs thousands of years to regenerate. It's not like bamboo. I mean, I think bamboo is a great material for architecture if you are in a country that gives you bamboo. But unfortunately, in the Gulf, we don't have that asset. So then this is why I turned to industrial waste. And I think, for a fact, the planet is moving more and more and more into desalination. population's booming, we're facing drought, so desalination is going to increase and increase and increase. But the question becomes, what do we do with this also reject brine that, you know, today the Gulf is dead because of this waste. I mean, there are no coral reefs anymore. The fish is all gone. Artemis is struggling. So the rest of all the other seas are going to struggle in the same way unless we really address this urgently now. And at the same time, I didn't mention that, but not only the marine life is dying, the temperature is increasing because salt plus water equals battery. So it's trapping heat, right? So it's also raising the heat in the sea and in the temperature surrounding it.
Thank you. That was great. I really enjoyed that. And as an anthropologist, find myself just having my mind expand in the age of planetary crisis of various orders. So I thank you for being an emissary from the future. I have a question about hybridization. So as a material that might become useful for a future that is increasingly warming, how would this travel to other parts of the world, and how would it relate to other materials? So I'm thinking of mud, snow or ice, igloos, for instance, or mud-thatched homes. So just interested in your perspective on the hybridization of this material with other materials that might be then used to actuate a kind of habitation or a habitable environment. And the other question is just a clarification, which is the thing about reinforcement with palm. When I hear the word palm, things go awry in my mind because of palm oil and, you know, the promises foretold and dashed because of that, the forests that have been pillaged because of the production of palm oil. So I just wonder if you can say a little bit more about the process of using palm to reinforce, and if there are other alternatives that you think might be useful or possible to use to reinforce the sabkha structure.
Right. So first question is that we refuse for, you know, we don't think it's smart for any material to travel. Your material has to be local. And so that's why I'm saying, you know, this material only makes sense to use in countries that have reject brine of desalination water. Otherwise, you know, you shouldn't be using this material at all. I have not investigated mixing the magnesium oxide with other materials. Like, we do mix it, I mean, with different other salts, but there is a certain formula for it to be non-soluble, and that's quite restrictive. Palm fiber, we reinforce it with palm fiber, and the palm fiber we collect from the all the, you know, the municipality. They trim all the palms in the Gulf, and then they take that palm and they throw it in dumps usually, which is they don't do harm to the environment because, you know, they will just go back. So we take that actually. So we ask the municipality, rather than throwing that truck there, can you bring it to our lab? And they just bring it. So it's not about mass producing palm to reinforce that. No, we're again trying to think of a waste product that's naturally coming from trimming the palms and combining it with the reject brine.
Take the last question if anyone else has one. But thank you so much for this talk. It was super, super inspiring to see how you kind of followed this rabbit hole and really took the momentum and went for it in a place where that momentum wasn't there to begin with. It was counter to other building practices. So I had two questions. The first one is related to lifespan of this material and how you're conceptualizing what you found and discovered in relation to the lifespan of potential structures in the future. And the second question, as sort of students and young designers, is how did you find this momentum to keep going? And if you had any advice for how to get that process started, because I can imagine that it wasn't super easy to begin with.
Yeah. So how to keep the momentum again? I think, you know, as a practicing architect, I think I wouldn't have put much effort into this project had I not been a practicing architect, honestly. And because of the guilt that comes on the other side because of, you know, practicing, and we use Portland cement, we try to avoid, we use shipping containers in one project, prefabricated steel structures in another project, but sometimes you do have to use materials that are catastrophic to the planet, and we still use them because I'm not going to give up my practicing career anytime soon. Hence, that sense of frustration pushes me to really focus and delve deeper into finding alternatives, because then I can convince myself that, you know, what I'm doing here, if this pays back after 10 years, then whatever crime I'm committing here is okay, you know, kind of balancing it out in a way, you know. And I think that's really the drive. This is honestly where the drive comes from. It's you know, wanting to continue my ambition as an architect and trying to find a way to make it happen.
Well, thank you so much. I just wanted to say a couple of things to, thank you so much. Let me just say a couple of things to close out, not just this lecture, but our lecture series for the spring semester and indeed for this academic year. I had a very exciting meeting this morning about next year's series. I can't give you a specific preview, but we look forward to you joining us again for that. In the meantime, let me thank very much our lecturer tonight. Let me also especially thank Professor Huma Gupta, who's organized not only this lecture in our larger department series, but an amazing